Previously, we talked about 5 reasons you should consider 3D printing for your product or invention, but in this video, we're going to touch on 5 reasons why you might not want to use 3D printing for your design. Let's get started. How's it going, guys? Angus here from Makers Muse. Now, 3D printing is an amazing technology, and as we talked about in our previous video, it is perfectly suited for many use cases. But not all. It is not a silver bullet for anything that you need to manufacture and produce into a tangible object. It does have very inherent limitations, and it's not perfect. There are better processes for some use cases. So in this video, we're going to talk about 5 reasons you might not want to 3D print your object. And again, this is aimed more at industrial users of 3D printers, not those of you at home, because if you own a 3D printer, again, you'll come up with pretty much any use case to employ that 3D printer. But if you're in industry and you need to produce an object, then it's a little bit different. So let's start with number 1. 3D printing doesn't scale. This is a big one, and when I worked in the industry, it caught me a lot of times. So 3D printing an object, let's say it takes 1 hour to produce one little widget. Not so bad, you can produce that easily. Let's say the client wants 10, okay. 10 times 1. 3D printing doesn't really scale. There are some processes where you can do a large bed of parts and it can be a little bit faster to do a batch, but really, generally, producing many objects takes the same amount of time. I actually have this book, the Chris Hughes Pan Management Guides to Production and Operations Management. Exciting stuff. This is actually from the 1980s, and it has a fantastic graph in it which compares different manufacturing approaches. It has mass manufacturing, batch manufacturing, and jobbing. And this is before 3D printing was even really a thing, but 3D printing relates to jobbing, where you produce one at a time, almost at a bespoke level. And the graph clearly shows that as your quantity goes up, it goes straight through to the roof in terms of cost. So one-off on jobbing is cheaper than mass, but mass production to produce many things is far cheaper than the jobbing, or in this case, now in the 21st century, 3D printing. So if you want many, and I'm talking like thousands of an identical object, 3D printing is not the right process. You really do need to go to a more suitable mass production technique like injection molding. Reason number 2 is part strength and part quality. 3D printing will not produce parts as aesthetically clean and accurate as other processes, nor will it produce parts as strong as other processes. That layer-by-layer process is an inherent weakness in many 3D printing technologies, where it's almost like a wood grain. Especially in FDM, fused deposition modeling, it is a molten plastic process, and the layers it builds up are the weakest point. Whereas with injection molding, it is a seamless, uniform, flowed, molten plastic object that is solidified and is very strong. Also, CNC machining will work from a billet of aluminium and then machine it back subtractively to produce that part, and it's very strong. Whereas even now, metal powder printing processes can't quite achieve the same level of strength, although they are getting close. So keep that in mind if your part needs to be highly developed aesthetically, or very strong, or very rugged and needs to survive very demanding applications. 3D printing just can't reach above these other more established, stronger manufacturing techniques. Reason number 3 is very messy, and that is certification. So in the world of, for example, the food industry, products need to be food safe certified, food grade. It's a big thing, it's a big issue. And 3D printing isn't really able to be certified, because if you imagine you have a design, it could be different on other people's machines. Someone might print it where it is safe for food contact. Someone might print it on a machine that's dirty, or maybe it's got contaminations on it, and it's not safe for food contact. And it's the same design. So certification is very messy for 3D printing, and it's one of those areas I'm actually keeping a keen eye on because it hasn't really been solved yet. You might have food-grade plastics, but the layer-by-layer process of 3D printing technology means that even if the plastic's food grade, the material might get stuck into the actual 3D printed matrix itself, and you can't clean it, therefore you can't properly make it sanitized. Now there is like autoclaving processes for medical, and that is definitely a good way to keep 3D prints clean, but most 3D printed plastics will not survive an autoclave. So it's very difficult at the moment to guarantee certification for 3D printed parts, whereas compared to injection molding, you can keep that system a lot more sterile, and it's easier and more, I guess, and more familiar to the whole certification network than 3D printing. That is a big struggle right now, is getting things certified. Reason number 4 you might want to consider not using 3D printing is it just might not be the right suitable process. If your object is quite simple geometrically and you can produce it on far cheaper manufacturing methods, like for example you want a block of wood, just cut a block of wood. Why would you 3D print a block of wood or a shape like that when you can just produce it with far cheaper manufacturing methods? And these books here, these aren't just props. I've used these for many years to inform my design decisions when it comes to manufacturing an object. For example, laser cutting. Laser cutting is a far faster 2.5D process where you have a sheet of material, plastic or even metal, and a laser cuts it away into 2D shapes which have a bit of depth, which is the thickness of the material. And it's far quicker and far easier to do than 3D printing, and the parts can be very strong because you can cut them out of metal. And it's actually cheaper as well. So there's many processes that you should consider as alternate processes if your design is suitable. Again, not all designs are suitable. 3D printing does have very low geometric constraints versus a lot of these other processes, but if you can get away with them, you can save yourself a lot of money and time, and also get yourself a actual superior end product. You just got to think in a different way. You know, how can I make this object and what process can I employ to make it as well as possible? So let's finish up on number 5 for the reasons you probably shouldn't use 3D printing for your design or invention is a lack of understanding of the core limitations of the 3D printing process. So this is an overall arching thing, and basically you need to understand that 3D printers are not silver bullets, and they do not solve every issue by just printing it. And I've met many designers, I study with many industrial designers, who just got used to the idea of we'll just 3D print it. It's easier, it will just do it, it's quicker. But in the end, a lot of these designs weren't. For example, to design a dome like this, with a few bumps on it, 3D printing that is possible, but you'll have all this support material underneath it. Why not do vacuum forming, where you have a sheet of dirt cheap plastic and a buck, and it just forms over the top of it, and you end up with an object, you just trim away the excess. And you can make multiples. So when it comes to 3D printing, even if you're just using it from an industrial level, you're a designer or an inventor, and you just want to create an object, really consider that 3D printing, while it is very magical and powerful, does have inherent limitations. And you need to keep that in mind when you're designing objects. For example, 3D printing can't produce very good optically clear objects. Even now, the optically clear objects go yellow over time because the resins aren't very UV stable. And the parts aren't going to be very strong. If you want very high detailed resins, then the resins that are tough and you want them to be tough are only available in limited colors. So when you're working with someone who is in the rapid prototyping field and you want to get something done, actually put some faith into them when they say no, that's not possible, because most of the time it isn't, and an alternate process might be the better way to go. So hope you guys enjoyed this video on 5 reasons you probably shouldn't use 3D printing for your design or invention. And if you missed the first video where we talked about 5 reasons you should consider using it, go check that out because it's a lot more positive. And as I always say here on Maker's Muse, I aim to empower your creativity with 3D printing. And if you enjoyed this video, I'd love to have you subscribe. Thanks for watching, guys. Bye.
Here's the latter half of the 20th century. And man has sent rockets into deep space. He has placed satellites into orbit.